There are millions of compounds that fall under the branch of organic chemistry. To easily identify these compounds and their structure, scientists have assigned names to these compounds. The system of assigning a name to a compound is known as nomenclature. There are two systems for naming organic compounds: the common or trivial system and the IUPAC system. Let's look at the trivial system. The trivial names are given on the basis of the source and certain properties of organic compounds. For example, citric acid is named so as it is found in citrus fruits. Formic acid is named so as it is obtained from the destructive distillation of formica, which means red ants in Latin. This system was commonly used before 1892, and it did not follow any standardized rules. Moreover, more than one common name is given for certain compounds. To remember the common names given at random for large number of compounds that are discovered day to day is difficult. Hence, the need to develop a systematized method for naming organic compounds is found to be indispensable. Thus, in 1947, the IUPAC, that is the International Union of Pure and Applied Chemistry System of naming compounds, was first developed. The IUPAC system of nomenclature is a set of logical rules devised and used by chemists in which the name of a compound correlates to its molecular structure, thus making it intuitive for a person to deduce the structure from the name. However, common names are preferred for the IUPAC names, which are lengthy or complicated. Let's understand how IUPAC names are assigned to various compounds. The IUPAC name of an organic compound basically consists of three parts: the root word, the suffix, and the prefix. A root word indicates the length of the continuous selected carbon chain. A chain which consists of up to 4 carbon atoms is assigned special word roots based on the common names of alkanes. Thus, the word root for 1 carbon atom is meth, 2 carbon atoms is eth, 3 carbon atoms is prop, and 4 carbon atoms is but. A chain that consists of more than 4 carbon atoms is assigned a root word derived from the names of Greek numerals. Thus, the root word for 5 carbon atoms is pent, 6 carbon atoms is hex, 7 carbon atoms is hept, 8 carbon atoms is oct, 9 carbon atoms is non, and 10 carbon atoms is dec. Now let's look at the suffix. There are 2 types of suffixes: primary and secondary suffix. A primary suffix indicates the nature of the carbon chain that is saturated or unsaturated, and the secondary suffix indicates the functional group present in the compound. A primary suffix is added to the end of the root word. It indicates if a compound is saturated or unsaturated, that is, whether the compound consists of a single or multiple bonds. The three primary suffixes are ane for alkane, ene for alkene, and ine for alkyne. A secondary suffix indicates the nature of the functional group present in a compound. Thus, the three components can be combined to form part of the compound name. For example, the root word eth, primary suffix ane, and secondary suffix all together form the IUPAC name ethanol. A root word eth, primary suffix ane, and secondary suffix oic acid together forms the IUPAC name ethanoic acid. If a functional group is present, then E of the primary suffix is replaced by the secondary suffix. Now let's look at the final component, the prefix. There are two types of prefixes: primary prefix and secondary prefix. A primary prefix is used to differentiate acyclic and cyclic compounds. However, the rules for using these are slightly different. For example, in cyclic compounds, the prefix cyclo is added before the root word. In the IUPAC system, some groups are not considered as functional groups. They are treated as substituent groups. In such cases, the substituent acts as the secondary prefix. Some secondary prefixes and their substituent groups are fluoro for fluorine, chloro for chlorine, bromo for bromine, iodo for iodine respectively. However, in acyclic compounds, the primary prefix is not used. So, if the prefix cyclo is not used, it indicates that the compound is acyclic, as in propane.